This is the Unit 1, the alphabet and grammar of geometry. Preview video 1.5, brain in hand. Problem solving part 1. Sit tall. Don't skip this step. Ready? Through the nose. Inhale. Hold for 3. Bring it down. Nose. Ready? Inhale. Hold for 3. Bring it down. That's 1. Ready? Inhale. Hold for 3. Exhale. Put your hands on your chest. Close your eyes. Take a deep breath. And drink it together. Don't forget date, time, and location. Students, what I'm about to tell you in the next 15 minutes about your brain will revolutionize your understanding of math, specifically geometry. There's going to be a lot of neurology, which is the study of the brain. You need to know my original profession was in occupational therapy, which is a rehab health profession. And so that gives me my background in neurology. It has given me also my background when it comes to education, is to figure out how does your brain work, how to help your brain work even better, more effectively, and more efficiently. And I'm talking about your brain, not artificial intelligence. Quick background. About 15 years ago, I noticed that I'd be doing problems on the board, and it would be something as simple as like this angle's 50 degrees, this angle's 60 degrees, and this angle is unknown. And I would have a student at the board just kind of staring at me with their hands folded, and they would be like, I don't get it. And I'm like, this is an easy problem. What's going on? And I found myself grabbing students by the hand and helping them trace the triangle and sweep the angles. And as soon as I did that, I got this reaction. Oh, it's just 180 minus 110. And that reaction, I saw it over and over again when students started interacting with the diagrams. And I noticed that I, as a digital immigrant, would automatically interact with diagrams, but you digital natives did not. And that I had to start coaching students to physically interact with the diagram because, and I was wondering what's going on with that reaction. And so I did my master's thesis on how digital technology is changing cognition. And what I knew instinctively, I now have the neurology, is that your fingertips and your hands in general are connected to the frontal cortex of your brain, the thinking part of your brain. That your brain just doesn't think from input through your eyeballs or input through your ears, but it also processes information it needs to solve complex issues through your fingertips. And the problem is technology is pulling you farther and farther away from interacting with the world around you using your own physical hands. We keyboard more than we write, and physically writing on paper actually increases understanding, comprehension. Note-taking on a notebook or tablet actually shows very little retention. We tend to click on stuff instead of physically shading and tracing and coloring. In general, we're tapping on screens more than we're physically touching the real world. Because we do more of this, it's actually causing our brains not to be wired together as efficiently or as effectively as God had designed our brains to be wired together. Another thing you need to know that's super important is that reading on a screen or a tablet is different than reading a physical book. If you're ever given the choice of an online textbook versus a physical book, you should always choose a physical book. On a screen, our eyeballs tend to just kind of wander. Therefore, we skim. That's why when you do web design, you have only about 3 seconds to grab people's attention. And if there's too much text on a web design, we tend to not use it because web design, digital, is not designed for close, careful reading. But when we're reading on paper, especially finger on paper that I have taught you, we tend to read line by line much more effectively and for detail. Key thought number 4 is this simple but revolutionary, is that if you increase the use of your hands and fingers, it actually increases the function of your brain. All of these key thoughts have been footnoted if you need the reference, especially if your parents are curious. And here is the most critical thing I discovered in my master's thesis is there's an actual spot in your brain specifically designed to process visual spatial mathematical relationships. It's called the left angular gyrus. If you put your finger behind your left ear, a little bit lower down past your earlobe, and you go about an inch inside your brain, that is called the left angular gyrus. Again, here's the neurology reference. That spot in your brain processes visual spatial information. Guess what? It's not connected to your eyeballs. It's connected. That means for you to process properly geometric diagrams and 3D models and the 3D world around you. When you're in physics class, remember this as well. You need to interact with your fingers and your hands. That's called finger gnosis, knowledge through your fingertips. Another thing you need to understand about solving complex problems, a lot of you are under the idea that first you have to understand something, ta-da, then you give effort. And I know this because a lot of students, they look at a problem that seems complex, they just glance at it, and in about 2.5 seconds, I get this, I don't get it. And then their hands usually go flaccid. Most of the time they drop the pencil, kind of fold their hands in their lap, and they're like, I don't get it. Problem is, you don't understand first, then give effort. It's actually the other way around. You give effort, and then your brain says, oh, I understand. You don't understand first, and then apply effort. Effort yields understanding. Which leads to the classic question, how do I give effort when I don't know what to do? I give you 5 things that you can do when you don't know what to do. This must be memorized. Number 1, you read the 3 body parts 3 times. Now we'll go over all of these in detail. When you read with your finger on the paper, your lips producing sound, and your eyeballs on the text. That's the 3 body parts. You do that once. Then you go through a second time and you filter, underline, or highlight keywords. Watch out for numbers and especially units, which are centimeters, meters. You interact physically with the geometric or math problem. You create a drawing, you label the drawing, you list all your given information, You cross stuff out as you account for it in the list. If you have the diagram, you physically trace with your fingers every aspect of that diagram. You can do all that without even knowing how to solve the problem. Number two, you don't know what to do. Get out your reference booklet and start flipping through the pages. Find something that looks similar. Number three, you ask yourself, what do I have? You start like this with your hands. You start with what you have, not with what you need. So don't focus on what the question is asking. Focus on what you're already given. Focus on what you have, not what you need. You ask, what do I have? You don't ask, what do I need? Squeeze the sponge means take the problem and squeeze out from what you have every single piece of related information that you can possibly get out of the diagram. You do like multiple aspects. You don't just look for one thing. You squeeze out of the diagram everything you could possibly get. I'm using the analogy of a sponge where a sponge is wet. You have to pick it up and dry it. You squeeze out all the water and then you wipe the counter. You need to remember when you work with equations that the equations have two sides with an equal sign. Do this with your hands. Say it out loud. Say equations have two sides with an equal sign. Do it again. Equations have two sides with an equal sign. Let me give you an example. Write this example down. If I ever ask you for the definition of slope, definition of slope is rise over run, which you guys have probably memorized in the past as y2 minus y1 over x2 minus x1. If I ask you for the equation for slope and you say, Miss Way, it's rise over run, y2 minus y1 over x2 minus x1, guess what? You're wrong. You don't write it like that. You write it like this. Slope equals rise or run. Equations have two sides with an equal sign. You never, ever just write the one side. The one side's called an expression, not an equation. An equation has, do it with me, two sides. And then step number 5 is when you're dealing with equations, you do something what I call circle plug chug. And I'll describe that in a moment. Circle means to circle parts of the equation. Plug means to plug the numbers in. Chug is my version of just get it done. Get it done. Geometry is a language of things. Your brain processes things through your fingers and your hands and your arms. That's what that left angular gyrus is all about. So these are phrases and words you're going to hear me a lot use in class. I'm going to ask you to trace and label stuff, sweep and label stuff, draw and label stuff, shade, finger pinch, and gesture. All of these you can see are cues that are related to the motion of your fingers and your hands. All of this is in an effort to get you to comprehend geometric relationships. These tactics also will come in very handy for your physics class as well. Let me give you a demonstration for each of these, what I mean. Trace and label. So, for example, if it says segment ED is perpendicular to CD, you would trace segment ED, you would trace CD. Perpendicular means right angle, so you would draw the right angle and write 90 degrees. In other words, as you read, you trace and label on the diagram. Here's another example of trace and label. Here's a rectangle. You're told, notice I'm reading with my finger on the paper. In fact, you read this out loud. Perimeter, ABCD, trace and label. So perimeter, you should always trace perimeter around. That's perimeter, means to go around, and then we label it. Perimeter equals 24 cm. Perimeter includes 2 lengths, 2 widths. Trace and label. Okay, sweep and label is used specifically with angles. And you're going to notice I'm going to have some colors. When you do angles, having multiple colors is actually extremely helpful. And the reason is our brain comprehends colors at a younger age than we comprehend numbers. If you've ever babysat really little kids, you know, and I'm talking like 1, 2-year-olds, you will notice you can talk about colors, point to something blue, point to something red. You can talk about colors long before you can talk about numbers. What is 2 plus 3? So colors is wired to a much more primal part of your brain. So you're going to notice I'm going to be using colors a lot. And one thing I like about colors, I'm going to show you how I do stuff fast, is what I call knuckle the color tops, kind of like a colorful Wolverine. I call this knuckling. And that way, when you grab colors, you can just off, clip, off, clip, off, clip. You can do it real fast. You want colors, go get them. You don't have to have colors. I'll show, just do this in straight up black and white. So right here, here's an example of sweep and label. It says, notice I'm reading first, measure of angle HGF is 160. The measure of angle FGY is 60. Find the measure of angle YGH. Here's how you would label, trace and label. I'm going to use colors. HGF, so I trace H, trace, and sweep 160. FGY, trace and sweep 60. YGH, YGH, trace and sweep question mark. And just by doing this, instantly you can see if you trace and sweep properly, that's 160. Use your fingers. Fingers, 160, 60. If you do that a couple times, you feel it. Bam! Oh, that's easy. That's 100. Ta-da! Trace and sweep. Trace and label, trace and sweep, draw and label. So out loud, read this. You mouthed it, you should have written, and then we're just going to draw it. We have an angle, PQR. Q is the hinge. P, PQR. Underline the word interior, QT. Notice Q's the end point. It doesn't say which way to angle it, but never put it in the exact middle unless you see the word bisect. So I'm going to offset it a little. T. Read, finger, lips, out loud, draw and label. The area of ABCD is 27. Area is a concept of shading. So when you're dealing with area, you should always give it just a light shade. That tells your brain you're in 2 dimensions. Shade. Finger pinch and bracket. Finger pinch means this. Finger pinch distances. You should bracket. So this is what I mean by bracket. We want to find ED. So we do this. We bracket E to D, put a question mark. Get your fingers, pinch. Super easy if you pinch this out. Go like this. That's 18. That's 6. 18. Follow. 6. And at some point, your brain's just going to go kind of, might be something like an O, or it might be an O. Okay. But you see, oh, it's just 18 minus 6 and 12. That's what I mean by finger pinch. So all of these, trace and label, sweep and label, draw and label, shade, finger pinch, bracket, and gesture. Your hands and arms should be flying all over the place when you're in geometry class, modeling what's being done. Let me give you an example of gesture. Really simple. It says line M is parallel to line N. So you should be doing something like this with your arms. Parallel means to go the same direction and never intersect. So parallel, parallel, parallel. Actually, a little arrow feathers, that technically means parallel. So you should gesture. So these are the kinds of things you should do to activate your left angular gyrus. Let's do a few problems together. Finger on paper, out loud, read. I read that out loud. Now we're going to bracket everything. F to D, so we go like this. F to D is 15. Cross it out. Notice I'm bracketing. F to E is 11. Whoops, nope. Should say 12. Change that. F to E is 12. Bracket that. And we have G to E, the whole thing, from here to here, and I'm going to bring it up from here to here, is 18. Find G to D, which is going to be this whole thing. Now, don't focus on that whole thing. Don't start with what you need. You start with what you have. And you just use your finger pinches and find stuff that's super easy to find. For example, if you finger pinch right here, put your fingers there, and then move from the spots, and then move your fingers to the X's. That's 15, 12, boom. Squiggle that, you just figured that out. That's 3. Ready? Finger pinch, try this one. Go from yellow to yellow, that's 18. Move your fingers right from here to here, that's 12. 18, 12, 18, 12, 15, 12, boom. Your brain just figured something out. All right, that's from here to here is 6. Let's see if you have sufficient information. Starting at G, you have 6, 12, 3, 6, 12, 3, 6 plus 12, 18, 3. We just found our answer, G to D, 21. bracket finger pinch. Activating the left angular gyrus. I'm going to do another problem with you using geometry. You're going to physically trace the entire diagram. So just literally put your fingers on the diagram, just like this, follow that little red dot, and just go through the process of just tracing every aspect of the diagram. Just trace it all over the place. The physical act of tracing helps your brain to begin to process the information. Activating. We're going to sweep the angles with algebra and numbers. We set up a thing equation. Geometry is about things. Then we're going to do an algebra, find x, solve for all possible angles. Okay, ready? It's important that you just don't willy-nilly mash the algebra together. So we're going to physically sweep the angles that have so we sweep that one. Sweep that one. How about you sweep from here to here and then sweep from here to here? You can feel we got a straight line. That's a little 90 degrees, which means from here to here, it's also 90. Oh, now we can set up our thing equation. Our thing equation looks like this. If I add, you don't have to use colors. The colors really make this pop a little. If I add the blue angle, the measure of the blue angle, that little m means measure of, plus the measure of the green angle, it's going to equal the measure of the larger red angle. That is a thing equation. Now we do an algebra equation. Circle, plug, chug, circle, blue angle, circle its contents, 9 plus x. Circle, please circle. Circle, C1. I'm circling that equal sign so I don't drop it. Circle the big angle, sweep, circle. The physical act of circling each aspect of your thing equation helps your brain not make mistakes in what you solve. This is a super easy problem. So I'm going to give you 20 seconds. I'd like you to do it yourself. No, you may not use a calculator. Use your fingers to count if you need to, okay? Go, 20 seconds. All right. We add these, collect like terms. I have x plus 70 equals 90 minus 70. And of course, x equals 20. Solve for x. Geometry never stops. Algebra was all about x. You solve for x, you're done. X is only a stepping stone to something else. So we're going to take that x, we're going to plug it in right there, and 20 plus 9 is 29, which, let's do a check, 29, 61, add 10, carry the 1, 90, check, that works. Okay, see that sponge? That means squeeze out every piece of information that you can. Guess what? You're not done. You're not done. What else could you find? Let's see, what else could you find? Put 2 dots there, 2 dots. Put your pen right there. Now, you sweep a rainbow from dot to dot. Sweep the rainbow. Go back, sweep the rainbow. Sweep the rainbow. Sweep the rainbow. And in about 5 seconds, your brain's going to go, oh, wait a minute. Oh, I get something. Which you do. From here to here is 180 degrees. Now, see these 2 x's? Squiggle, 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 squiggle. Ready? Use the 180, sweep the 29. Find the squiggle. You've got 20 seconds. Go. Don't use a calculator. Use your fingers. Ready? 20 seconds. Go. Well, we're doing 180 minus 29. It's basically 180 minus 30, which is 50, and then add the 1. So we have 151. You're like, oh, I did find everything. No, you didn't. Wait, there's still more. That's why it's called squeeze the sponge. All right. Ready? See these two X's right here and here? Sweep 180. Go. Sweep, 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 sweep. And now I want you to find that. You have 20 seconds. And you should have done 180 minus 151. And oh, looky there, it's 29. 29. And then this is already 90. All right, that's what I mean by squeeze the sponge. You take the diagram and squeeze out every drop of information. You never just solve for one thing. Ready? This page, I'd like you to do all by yourself, following the steps I've given you. Pause the video. Welcome back. These are the things you should have. Red pen, I'm going to be looking for things. You're not copying, you're correcting. You should have work on your paper right now. Do not copy. Get a red pen, you should be correcting. Ready, your thing equation should look something like this. And I will color code mine. You didn't have to color code, but you can sweep, trace, and sweep. I have one angle. Trace and sweep. I have another angle. And then trace and sweep. I have a third angle. You're like, wait a minute, I've got 3 angles. What's true about them? You go all the way around. You should have felt they add up to 360. So your equation, your thing equation is one measure of one angle plus the measure of another angle plus the measure of a third angle equals 360. Equals a circle if we're going to stay with our thing equation. All right, so your thing equation should look like this. Angle plus angle plus angle equals circle. Ready? Now we do circle plug chug. 50. And this was X plus 37. And then this was 228. We're adding equals 360. Students, I expect you to do this math by hand. It's good for the brain. So in the margin, we're going to go 228, 37, and 50. And 8 plus 7 is 15. Carry the 1. That's 6 plus 5. That's 11. Carry the 1. I have 315. Please train yourself to do basic computational math by hand. Good for the brain. Good exercise. Minus 315. And we get X equals 60 minus 10 is 50, minus 5 is 45. Okay, wait. Never stop with X. So we're going to go 45 plus 37. And once 12, carry the 1. And that's going to be 82. And then we have 228. You can do a check. 82 plus 50 plus 228. Then carry the 1. That's 9. 14, 15, 16, 360. Boom, there's your check. Things before algebra. We're in the home stretch here. Home stretch, I know this is longer than usual. You're almost done. Super important. I'll pick up the pace. Your first geometric equation is going to be perimeter and area of a rectangle. Perimeter, I always want you to trace it around like this. Perimeter, trace, 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 always trace. Perimeter's like a picket fence. Perimeter, if you walk it around, is going to be length plus, I'll color code it for you, length plus width plus length plus width. Length plus width plus length plus width. Length plus width plus length plus width. It is an additional concept. Now, you may have learned that a rectangle perimeter equation is 2 lengths plus 2 widths. I will never use that. I want this one because it physically represents what's going on when you walk around much more effectively. Perimeter equals length plus width plus length plus width in a rectangle. Area, I want you to get in the habit of always shading when you're doing area. And area is simply for a rectangle length times width. So perimeter is an addition concept. Area, shaded, is a multiplication concept. Recap, when you're dealing with variables, x plus x going to be 2x, x times x, x squared. There we go. One more problem together. I'm going to show you how brain in hand works with step number 1. Read with 3 body parts 3 times. Put your finger on the paper right here. Read aloud as I track with my finger. Aloud. I won't read aloud. You read aloud. Ready? Go. That's number 1. That's this. Now we filter. Key information, underline or highlight key information. It says the perimeter of the rectangle is 26 centimeters. There is an equal sign. So watch out for is, are, was, were. That's an equal sign. The longer side is 3 centimeters longer than is a plus concept, not times, QR. Find the area. Okay. Now we draw label list, cross out. You're not trying to figure this out yet. You're just, I call this getting the food out of the fridge. You're not cooking yet, the problem. You're just getting stuff out of the fridge and on the counter. So we write everything down. We draw, label, list, cross out. So first I'm going to label our rectangle length and width. It's PQRS. And PQ is the longer side. So I'm going to start right here. P, go longer. Q, shorter. R, and S. I went counterclockwise. As I account for stuff, I cross it out. So here, our perimeter, trace the perimeter, 26. I just write that down, 26 cm. Cross that out. I took care of all that. The longer side, PQ, that's an equal sign, 3 centimeters longer than QR. QR is our width. So it's 3 centimeters longer than the width. I'm going to label both sides equals 3 centimeters longer than the width. Notice we're not figuring anything out. All we're doing is getting the food out of the fridge. Draw, label, list, cross out. Draw, label, list, cross out. Find the area. Area equals question mark. You start with what you have, not with what you need. I know in general in the past, your brain has always been focused on what do I want? And then what happens is you focus, what do I want? And your brain says, I don't know. And then you go flop. I don't know what to do. Don't do anything. You don't focus on what you need. You focus on what you have. So we have the perimeter. So we go and what do we know about perimeter? Look it up in your reference booklet. So perimeter, see, I know this about perimeter. I can at least write the equation down. Length plus width plus length plus width. Write that down. Why did I do that? Because I'm starting with what I have. I have the perimeter. Well, let's see what else I have. Let's see if I can do some circle plugging, tugging. Watch. Circle, perimeter, circle, plug it in. Equals some circle. You're going to circle every aspect of the equation so you don't drop any piece of information. I circled the length. Come over here. Oh, I could replace the length with 3 plus W plus, there's another W. Keep circling every aspect of it, plus another length, which is 3 plus W, plus another W. By circling the pieces of the equation, you are less likely to drop a term. Now you just, oh, what can I do? I don't know. Well, wait a minute, I'm down to one variable. Could I solve for the one variable? Sure. Let's see what we can do. I have 4 W's, and 3 plus 3 is 6. Back to basic first semester algebra. The inverse operation of multiplying is dividing. And lo and behold, I just found my W. I found something. I wasn't even looking for it, but I found it. Why? Because you start with what you have. I found that it's 5, and you check for units. This is a length here, so you got to watch your units, 5 centimeters. So I just found my width is 5 cm. You ask yourself, oh, what else could I find? I found that. Well, means I can put 5 here. Trace, I just found my length is 8 cm. Let's see. What do I know about area? Well, I could write the equation for area. You just wrote it down here. Area equals length times width. It's circle, plug, chug. Area, I don't know it. Circle, circle. And area is 2 dimensions, so it's centimeters squared. So you don't focus on what you need. You start with what you have. You just keep asking yourself, what else do I know? This was a long but super important lesson. Please summarize what are the key thoughts that were new to you and revolutionary.